Today I'm going to give you an overview of the Universal Ledger open source project I worked on for a number of months last year. I wasn't able to get it quite so far as a universal ledger. It ended up mostly being a study in infrastructure components on a cloud-based architecture. I'll show you what those look like through the course of this video. The major components or technologies that I've chosen to use in this were Vagrant as the VM container. The Vagrant box that I chose was CentOS. It's a Linux distro. I used that initially just because of the database I thought I'd be using, but I ended up not using that database, so it's not dependent upon that in some way. The language environment I chose was Scala, and the build tool for Scala I used was SBT, the simple build tool, the Scala build tool. I also chose to use Play Frameworks as a web server and Spark as an analytical engine. I ended up trying two different databases and didn't end up using them too much, but a Derby database and a PostgreSQL database instance. You'll see some of those through the setup process. So the project in GitHub contains a Vagrant file in the root directory. The Vagrant file contains all of the parameters that are needed to start up the Vagrant system. I've already installed Vagrant on my PC. That's a very short process to download and install Vagrant. Once you've done that, then this file will tell Vagrant what it needs to create. The server we'll be creating is from this guy, Geerling Guy, who maintains a number of different Vagrant boxes. I chose one that was a CentOS version 7, and it's a very stripped down Vagrant box with not a lot of other components in it so that I could add the components that I wanted. It has a component that is the Vagrant guest additions. We'll show that later on. That allows for sharing of a disk drive between the host and the VM environment. So that's the thing that will initialize our Vagrant environment. I've named in this environment the server UL server, Universal Ledger server. You don't have to give things a name, but I chose to do that. You'll see why a little bit later. So these are the commands here that we'll be executing. So we go to a prompt, a Linux prompt in the directory that contains the Vagrant file. And if Vagrant's installed, then the command to start up the Vagrant environment is very simple. It's Vagrant up. And once Vagrant starts running, it will look for the Vagrant file in the same directory you're executing, and we'll begin to execute the Vagrant commands. We'll go through, it'll do a number of steps here. It initializes the operating system, it downloads the box actually first from the Vagrant server, and then it uses the box to initialize the operating system in the Vagrant environment. It adds network connectivity and basic security sort of parameters. At the completion of this process, you basically have a VM box running on side of your host that you'll be able to log into and look around just like you would with any other VM. Once we're given a command prompt back, if we type Vagrant SSH, Vagrant takes us inside the VM to a command prompt inside the VM. Once we're in there, we're taken to the home/Vagrant directory. If we change and go back to the root directory of the VM, we can see here's all the files that are in the root directory. We can go inside of the Universal Ledger directory. Once we look inside the Universal Ledger directory, we can see that we're actually sharing the same file structure that we're sharing from the host. So all of these names of these directories are the exact same file in both locations. It's the Vagrant guest additions that allows us to do that. So that's a little add-on to Vagrant that allows us to share that same file system between the host and the VM. You can see if we do a more document on the README or on the Vagrant file, we can see the exact same contents inside of Vagrant that we can see outside of Vagrant on the host machine. If we go further then, in my project, I actually constructed multiple servers in a single Vagrant file. This shows here the second server, and there's a third server at the bottom. These second and third servers, I didn't code with the auto start true parameter. They're false parameters. So when Vagrant starts up those, it doesn't automatically start these additional servers, additional VMs in the same Vagrant file. So if I go back to exit out of the Vagrant shell script, back to the host directory that contains the Vagrant file, I can then actually do Vagrant up and the server name for the additional VM that I want to have started. And this will then go through and do the exact same things based upon the commands in this script that were done for the initial startup of the server environment. At the end of the process, I'll have a couple of different VMs running in the same environment. Once we get a command prompt back again, just like on the original server, we can then go and SSH into the environment. If I open another prompt here, we can use one of these prompts to go and inspect the server side of things. Use another prompt to go see the additional server, the new client that has been set up as well. Once we get into those, it's possible to go forward and go inspect again the same directory and see that we can share the two directories. In fact, if from the client VM we do a touch command to actually create a file, we'll be able to see the file is created in the client. The file is also visible in the other VM, and we can then also see it inside of the host. If we delete the file, we'll then be able to see that it's deleted in all three locations at once, just showing the shared nature of the directory structure between multiple VMs and a single host. The command inside of Vagrant to close a VM is the halt command. If you use the halt command with the VM name, the machine name, you can halt specific VMs. Once you halt a VM, you can, there are also commands that allow you to look at the status. Here we can see our server is started, but the two clients are stopped. If we then stop the server with the halt command as well, we can then go and destroy all of these, which is the thing that will eliminate the servers altogether and allow us to clean up the environment if we want to do a rebuild from scratch. The project contains an initialize script that downloads the software needed to make the Vagrant environment more robust for what our development purposes are. If we SSH into the Vagrant environment, just like we did previously, and navigate to the Universal Ledger project and the scripts directory, we can then execute the bash script, and we'll talk more about what these pieces are that it's going to execute as it it does these in more detail, but basically it'll update the operating system, install Java, install Scala, install the SBT tool, and compile the play process. So the first piece of this process is to update the operating system. This just does the latest gets of whatever the operating system is and installs those in the Vagrant environment on top of the box that's been created. We also download a little utility called wget that's used in some of the other installation processes later on. The next phase of the process is installing Java and setting the Java parameters, the Java home parameters and such. Then downloading and installing Scala, and then it takes a little bit of time to get the SBT tool installed. The Play framework web server environment uses SBT Java. It allows Scala to test out our environment. So here the server is starting up, and we copy the URL from the README document. It's also there in the script. If we go open a web page to that, and it takes a little while because it's compiling the project while it's doing this, but once we get that open, the website picks up, and we're now looking on the host side at the website being served up from our Vagrant environment with the Java, Scala, SBT, and Play components all having been installed. The project also includes a setup script for the Derby database, a lightweight document database that could be used inside of the Vagrant environment if there was a need for that. Could be used against Play, the web server will show later on, and against Spark. So it's a lightweight, simple little process. Installs the database, downloads it, and executes the version command so that then it shows what version of Derby was installed. The Spark setup process begins by executing the Initialize Spark script in the script directory. This process begins downloading the version of Spark specified in the script and setting up the environment. It includes creating the Spark home environment variables and installing the pieces that are required of the Spark process. The script then executes the Spark version command. We see which version of Spark is running, just testing that it's been installed correctly. It then begins by compiling components of the project, another Spark application that's written as part of the project. The application will take a parameter file, has a SQL-like language to it, and read a file and do a series of transformations against that. This simple little test process just demonstrates that the Spark environment is created and could be used appropriately inside of the Vagrant system. The Play framework is used inside of the Vagrant environment in the VM to serve up web pages to the host. It's a process that allows creation of web content without having to have the full HTML authoring capabilities. It does the routing of web pages and request and post. The controllers handle the routing and request and gets and put and post. The home controller is the first one that executes as the system starts up. There are these small snippets of code that are used to generate HTML instead of having to write full web pages. You can see these are fairly compact rather than all of the materials you would typically have to write to get the fully formatted frameworks. You can see here the menu items that show up on some of the pages as we go and look at the mock-ups. These are the different mock-up screens showing here on the right-hand side. Those are the components and how they show up. So you can see it's fairly compact in the way they're structured and the way they're controlled. In the process, I wrote a controller that would list files, allow for a file transfer up to the host machine, basically from the host to the VM. It also, at one point, I had it working so that it would list that file and would then allow you to click on it and submit it to be run in the Spark process, but wasn't able to get that, retain that as I went through a few gyrations. I was also able to get the process to connect to a database, but not able to complete that process. If we look at the VM command prompt, you can see it'll give you some commands there, and you can write to the command prompt to see additional screens, those sorts of things. It's quite a powerful tool. A lot of different releases on it, accepts multiple languages, including Scala, but also Java and others, from which you can create these web pages and your server and control them in a very effective manner. So in this tutorial, I've shown you ultimately how to use Vagrant to create a VM, how you can set up scripts to download and install software in the VM environment, including Java, Scala, SBT, Derby, Spark, and then how you can make those components run inside the VM, serve up web pages to the client, have multiple VMs that speak to each other and communicate for different kinds of simulations or different kinds of processes. The basis of this may be useful for other projects you may be involved in.